Hey guys, welcome to a series of videos on networks and graphs. This first video is on what are graphs, basically, and I'm going to talk to you now about where do graphs come from. So in a minute we'll learn more about the key terminology, but a graph is basically something like this, where you've got a series of dots and then lines, and we want to devise key information from that and solve problems. But this all came about from this guy here, Euler, and the Konigsberg bridge problem. And Euler thought to himself, in this little city of Konigsberg, you can see the red things are bridges. And he asked the question, can you continuously walk, go on a walk? So if you say you start here, and you go over this bridge here, and then over that bridge there, and back over this, can you cross all the bridges only once without going over another bridge? And the answer is no, and we'll find out why that is in the future, but that's turned out to have some amazing applications. Okay, so what Euler did is he sort of used mathematics, and he sort of reduced the problem from being a town to being something like this. This is what we see a graph as today. Basically, where, as I said, some dots and lines which are connected. And so through Euler, this sort of graph theory and the mathematics behind it has led to sort of some amazing innovations. One of the most obvious ones might just be computer networks. So if you have a series of computers which are linked together, how you share information is really, really important. And obviously, my head's in the way a bit now, but platforms like TikTok and Instagram would use graph theory as a basis for their function, that's really important because I guess it's used to make money nowadays. TikTok was being offered for $50 billion the other day, so you can see how much money is in it. Another example might be transport and logistics, so how road networks come together, or how a supply chain works in the world. If you can make a supply chain more efficient, you can save billions and billions of dollars and make money in the process. And another more interesting one, well, not more interesting, but more complex one, might be molecular structure. So how do molecules interact together could be referenced with a graph. Okay, so, but the key lesson today is what is a graph? Okay, so I'm going to talk to you about that. And you basically have to tell me what are the key elements of a graph, and I need you to be able to define me these key words, and then do these questions from the Cambridge text. Okay, so all the questions, all the references I'm using now are from your textbook in Cambridge. Okay, so let's move my head. Okay, so graph elements. The definitions. A graph is a diagram that consists of a set of points called vertices. So these little the dots, I suppose you'd call them, are called vertices for plural, or vertex for singular. So one single dot is a vertex. The plural is vertices. Vertices. Okay. The lines that join them together are called edges. Okay. So this blue line here is an edge, and an edge will join two vertices together. A loop is just when one edge is connected to one vertex. Okay, so a loop looks like a loop. Two or more edges that connect the same vertices are called multiple edges. So just because you have one connection between two vertices doesn't mean you can't have another one. So you could have multiple edges there. You could have a third edge like that if you wanted to. There's no limit to how many you can have on a graph. I want to erase that though now. How do I do that? Eraser, so I get rid of that. Okay, the degree of a vertex, so we're sort of going through these key terms. We've talked about graph, what a graph is, vertex, edge, loop. The degree of a vertex is the number of edges that is attached to that vertex. Okay, so for instance here, this edge here, so that vertex there, if we call that A, they're normally named A, B, C, D, like that. If we call that A, the degree of A, deg A, is 2, because there are two edges that connect to A. if we call this B, the degree of B, deg B, would be 4, because there's 1, 2, 3, 4 vertices that are connected, edges that are connected to that vertex, pardon me. Okay, with a loop, it gets a bit trickier. So if I call that C, this loop will add a 2 to the degree of C. Okay, so there's 1, 2, 3, 4. The degree of C is 4. Okay, that this loop here, which I'll colour in red, colour in the loop red, that adds degree 2. Okay, so a loop always adds degree 2. Okay, by this note down here. Okay, so with the degrees of vertices, they can be either odd or even. Okay, in this case this is even, because it's an even number, 2. This is even as well. This is even, because that has a degree, if I call that D, that has a degree of 2. And this is even as well, because it has a degree 4. Okay, that becomes really important later on, odd and even vertices. So I could say all vertices are even in this graph here. Okay, because I can count the degree of them and I can say they're all even. Okay, last key important point from this lesson is in any graph, the sum of the degrees of the vertices is equal to twice the number of the edges. Okay, so if I was to find the sum of V, okay, so V means vertex, the sum, I might copy that out properly. The sum of V, okay, I'll change color just so so I can say that's 2 plus 4 plus 4 plus 2. Okay, is that right? 2 plus 4 plus 4 plus 2. So the sum of the vertices in this case is going to be 12. Okay. From this relationship, I know that 12 is equal to 2 times the number of edges. Okay, so I should expect there to be 6 edges if I count them. So 1, 2, 3, 4, 5, 6. Okay, so that relationship holds, and it will always hold. So if you need to know the number of the sum of the degrees, you can work that out very quickly by counting the edges and then multiplying by 2. Okay, so if that number there is 6, 2 times 6 is 12, and you get an even, an equal relationship, an equivalent relationship. So you now need to write some notes. It's really important to write down some notes for this topic because there's lots of definitions that you need to understand, and then you have to do questions like this in your textbook. I'm only going to accept it as complete if you draw out the graph like this, okay, and show me what it looks like, and then I don't mind if you just put 1 like that and then write the answer, but you need to draw the graph. Okay, draw the graphs. Okay, that's important. Okay, good luck.